Hello everyone. Today we are going to dive into the world of serverless applications and explore how Amazon CloudWatch Metrics and Alarms, coupled with AWS CDK, can help you build robust and reliable monitoring system for your application. We'll explore how to set up monitoring for typical serverless applications that consist of Amazon API Gateway, AWS Lambda, and Amazon DynamoDB. And first of all, let me introduce myself. My name is Artyom, and I'm thrilled to be your guide on this exciting journey into the world of serverless monitoring. As a ClickAttack team member, I have had the privilege of working on a very interesting project and diving deep into the area of AWS services and its monitoring. With my experience as a developer and passion for leveraging the power of AWS CDK, I'm excited to share with you useful tips that can save you a lot of time, nerves, and potentially even save money. In this presentation, we'll cover a range of topics related to Amazon CloudWatch. First of all, we'll talk about Amazon CloudWatch as a service and why it is important for us to use it in our serverless applications. We'll start by exploring the different types of metrics available in CloudWatch, including default metrics, detailed metrics, and custom metrics. Then we will dive into how you can use CloudWatch alarms to create alert notifications based on metrics, how to create composite alarms, and add possible alarm actions. We will also take a look at some examples of alarm graphics to show you how they can be used to display your metrics data in easy-to-understand format. Finally, I will demonstrate a real use case scenario where you will learn how to unlock the potential for saving up to $1 million by just applying all these concepts to a serverless application. And of course, we'll leave time for Q&A session at the end of the presentation where you can address any questions you may have. Before we dive into the exciting world of Amazon CloudWatch, let's start by understanding what it is and why it's so important for managing our AWS applications. Amazon CloudWatch is a cloud-based monitoring and management service offered by Amazon Web Services. It allows us to collect and track metrics, and as a result, respond to errors and unwanted behavior in a timely manner. As you all may know, Amazon CloudWatch is a popular choice for storing and analyzing logs generated by different services in your applications. However, it's important to know that CloudWatch is more than just a logging platform, and while it's commonly associated with its logging capabilities, it's a comprehensive platform that provides several features beyond log storage. One of the CloudWatch core features is metrics. AWS services like Amazon EC2 or AWS Lambda put metrics into CloudWatch, and you can retrieve statistics based on those metrics. With metrics, you can visualize performance data, set alarms based on this data, and take specific actions. As it was mentioned, CloudWatch also provides alarms management, which allows you to set thresholds and receive notifications when performance or metric values exceed certain levels. This feature enables you to quickly identify and resolve issues, minimize downtime, and optimize application performance. In addition to setting thresholds and receiving notifications, CloudWatch alarms also allow you to specify actions that should be taken when an alarm is triggered. For example, you can configure alarms to send an SMS message via Amazon SNS service, or even automatically scale your application to handle increased traffic via AWS autoscaling. We will not focus on CloudWatch dashboards in this presentation, but it's worth noting that there are customizable homepages that provide a centralized location where you can monitor your resources and metrics in a single view. With dashboards, you can quickly get a high-level overview of your application's health and performance, making them a valuable tool in your monitoring toolkit. To kick things off, let me show you a handy diagram that demonstrates how a common serverless application comprising of Amazon API Gateway, AWS Lambda, and Amazon DynamoDB interacts with CloudWatch. Here we can see that all services send their data into CloudWatch Metrics. Think of CloudWatch as a central location where the metrics from different services are stored. We can consider each service's metrics as files within a folder that is stored in CloudWatch. Let's move forward, and as we continue, the concepts that we are discussing will become clearer and easier to understand. And let's start by getting to know one of the most important aspects of CloudWatch, metrics. Metrics are data about the performance of your systems, which are sent by AWS services to Amazon CloudWatch. In CloudWatch, metrics are uniquely defined by a combination of a name, a namespace, and 0 or more dimensions. The metric name is a string that identifies the specific metric that has been collected, such as successful request latency or duration. On this slide, you can see examples of metrics in JSON format reported by CloudWatch. The first example tells us that successful request latency metric for a DynamoDB table with the name myTable and for the getItem operation has value of 123 milliseconds. The second example illustrates an invocations metric for a Lambda function named myFunction. The value field indicates that this Lambda function was invoked 10 times during the specified time period. Moving on to the next component of metric uniqueness, let's explore the metric namespace. Metric namespace is an important aspect of CloudWatch, as it allows you to organize and group metrics by service, application, or any other logical grouping that makes sense for your monitoring needs. The namespace is a container for the metrics and can be thought of as a grouping mechanism. For example, metrics for an Amazon API Gateway service might be organized in a namespace called AWS/API Gateway. On this slide, you can see how it looks like in CloudWatch. AWS namespace contains multiple folders inside, including Lambda namespace folder and DynamoDB namespace folder. Metrics in different namespaces are isolated from each other, so that metrics from different applications are not mistakenly aggregated into the same statistics. Now that we understand the importance of metric names and namespaces, let's consider the last part of metric unique key, dimensions. Dimensions, which are name-value pairs that provide additional information about the metric, are optional. They can be used to distinguish between different instances of a metric, such as different EC2 instances or Lambda functions. For example, the dimensions for a Lambda function might include the function name or version, or any other name we want that can further help us identify the needed metrics, among others. Every metric has specific characteristics that describe it, and you can think of dimensions as categories for those characteristics. Dimensions help you design a structure for your statistics plan. You can use dimensions to filter the result that Amazon CloudWatch returns. The slide displays the dimensions of Lambda as they appear in the AWS CloudWatch console. As I said, we can literally filter out Lambda metrics by resource or by function name. After learning about the basics of metrics, let's dive deeper into the different types of metrics that are available in CloudWatch. There are 3 types of metrics. Basic metrics, available for free, provided by many services by default. Detailed metrics, paid option on some services, and custom metrics. And let's start by basic metrics. AWS Lambda provides several default metrics, and I'm going to tell you the most common ones. The first metric is invocations. It is a metric that represents the number of times your Lambda function has been invoked in a given time period. This metric is essential for understanding the overall usage of your application. Moving on to the next important metric, we have the duration metric. Duration metric represents the amount of time it takes for your Lambda function to execute, including any initialization time. This metric can help ensure that there is no waste of the budget. If the duration is too long, it may be an indication that the function is looping or running inefficiently, leading to unnecessary resource consumption and increased costs. Another important metric is the errors metric. This metric represents the number of errors that occur when executing your Lambda function. Now let's talk about the totals metric. Totals metric represents the number of times your Lambda function is totaled due to exceeding concurrent execution limits. Monitoring this metric helps to identify if your function is frequently throttled and adjust the concurrency limit accordingly, thereby increasing fault tolerance and request processing time. And last but not least, the concurrent executions metric. Concurrent executions, it is a metric that represents the number of concurrent executions of your Lambda function. This is a crucial metric to monitor in a serverless application. By setting the concurrency limit, you can control the number of instances of functions that can run simultaneously. This can help you manage the cost of running your application. By monitoring this metric, you can ensure that your application is performing optimally by preventing overloading of resources and reducing the risk of throttling. You may see an example of how you can access default Lambda metrics using the AWS CDK for TypeScript. There are 2 ways of how we can receive metrics from our Lambda function. First, by using the metric class provided by the AWS CloudWatch module from CDK. As you see, in this case, we have to clarify metrics name and namespace. And second way is by using the Lambda function class provided by the AWS Lambda module from CDK. This class allows you, first of all, to define a Lambda function, and then we can retrieve its metrics within built-in functionality. Okay, are you still alive, guys? I hope no one feels like this man in the picture. Don't try to remember all these metrics names. You can find everything in AWS documentation. And yes, I only tell you about the most necessary metrics that you must have in your application. In the documentation, you can find many more metrics for your specific cases. But anyway, I'm planning to provide you with even more metrics and their names, so just bear with me. Since Lambda functions are often triggered by API gateway, it's essential to also monitor API gateway metrics to gain a complete understanding of how your serverless application is performing. By combining metrics from Lambda and API gateway, you can better identify and diagnose issues that may impact the overall performance of your application. Amazon API Gateway provides several default metrics that you can use to monitor the performance and usage of your APIs. And here are some of the most common default API Gateway metrics. We have the latency metric, which measures the time it takes for API Gateway to respond to a request, including the time for processing the request and the time for waiting for a response from the backend. Monitoring this metric helps identify any potential bottlenecks in your application. Additionally, we have the integration latency metric, which measures the time it takes for API gateway to receive a response from the backend after sending a request and includes the time spent waiting for this response. Another important metric to track is the count metric. It is a metric that counts the total number of requests that are received by API gateway. Furthermore, we have the 400 error metric that counts the total number of client errors, and 500 error metric that counts the total number of server errors returned by API gateway. Here is an example of how you can access default metrics using the AWS CDK for TypeScript. The code creates a new CloudWatch metric called Server Errors metric using the CloudWatch metric constructor provided by the AWS CloudWatch module from CDK. The metric represents the number of server errors for our API gateway. The namespace property specifies the namespace of the metric. In this case, it's AWS/API gateway. And finally, the dimensions map property is an object that contains the dimension name value pairs for the metric. In this case, the dimension name is API name, and its value is my API. And the same example, but for client errors that might be returned by API gateway. When working with Amazon DynamoDB, it's crucial to monitor the performance and health of your tables to ensure they are running smoothly. Fortunately, DynamoDB comes with a set of default metrics that you can use for this purpose. Let's take a look at some of the most common ones. And let's begin with consumed read capacity units and consumed write capacity units metrics. These metrics show the total number of read or write capacity units consumed by your DynamoDB table over a specified time period. DynamoDB pricing is based on the consumption of capacity units, so tracking these metrics can help you monitor and optimize your costs. Additionally, if your table is experiencing high levels of read or write activity, monitoring these metrics can help you to identify potential bottlenecks or capacity issues. The next metric you might want to consider is total requests. This metric shows the total number of requests that are throttled due to exceeding the provision throughput for your DynamoDB table. Tracking this metric can help you identify if your table is consistently exceeding its provision throughput and may require additional capacity to meet demand. Once you have identified any potential capacity issues, it's important to track the average time it takes for DynamoDB to process successful read or write requests to your table. This is where the successful request latency metric comes in. And finally, system errors metric. It is important to monitor any errors that occur on the DynamoDB service side when processing requests to your table. By tracking this metric, you can quickly identify and address any issues that might be impacting the performance and health of your DynamoDB table. And here is an example of how you can access default DynamoDB metrics using the AWS CDK for TypeScript. By using the table class provided by the AWS DynamoDB module from CDK, we define a DynamoDB table, and then we can retrieve its metrics within built-in functionality. In the first example, we retrieve the system errors metric. You can see period and statistics parameters that can be specified optionally. By default, the period parameter is set to 5 minutes, and the statistic parameter is set to average. In the second example, I show how we can specify an operation type and get total requests metric only for put item and get item operations. All right. So those are the default metrics that come out of the box with AWS Lambda, API Gateway, and DynamoDB. They provide valuable insights into the overall health and performance of your services and can help you optimize your costs and troubleshoot issues. But what if you want to dive deeper and get more granular data on specific aspects of your application? Well, that is where the detailed metrics come into play. In the next part of our journey, we will explore two powerful tools that can give you even more visibility into your AWS environment. And let's start by exploring AWS Lambda Insights Enhanced Metrics. Lambda Insights is a monitoring and troubleshooting solution for AWS Lambda that provides enhanced visibility of the performance of your serverless applications. Enhanced Metrics is a feature of Lambda Insights. It includes a range of additional metrics beyond the basic metric provided by Amazon CloudWatch. The solution collects, aggregates, and summarizes system-level metrics, including memory usage, CPU utilization, cold start, and network. Lambda Insights use a new CloudWatch Lambda extensions, which is provided as an AWS Lambda layer. And then Amazon CloudWatch uses embedded metric formatting to extract metrics from the log events. After it, you can find that your enhanced metrics are available as time series aggregated data in CloudWatch Metrics in the Lambda Insights namespace. Let's talk about some of the most common Lambda Insights metrics. The first metric is max memory used. This metric shows the maximum amount of memory used by your function during execution. It is a critical metric because Lambda function run within a memory-constrained environment. Another useful metric is the memory utilization metric. This metric shows the percentage of memory used by your function during its execution. A very useful metric in a serverless application. If you notice that your function is consistently using less memory than what you have allocated, you can reduce the memory allocation to save costs. Conversely, if your function is consistently running out of memory, you may need to increase the memory allocation to ensure that it runs efficiently. Moving on to the CPU total time metric. This metric shows the sum of CPU system time and CPU user time, or in other words, the amount of time the CPU spent executing code. Lastly, the init duration metric shows the amount of time spent in the init phase of the Lambda execution environment lifecycle. When a function takes too long to initialize, it can impact the overall performance of your application. Please note that Lambda Insights is a paid feature of AWS. You are charged based on the amount of data received by the service, measured in gigabytes per month. The example on the slide illustrates how to create a basic Node.js function with Lambda Insights enabled using the AWS CDK in TypeScript. For this purpose, we need just to specify the Insights version field with needed version during Lambda initialization. And then we can retrieve the needed metrics in the Lambda Insight namespace by using the metric class provided by the AWS CloudWatch module. The second tool that can give you more visibility into your AWS environment is an API Gateway Access Logs. API Gateway Access Logs provide a great opportunity for you to gain additional metrics beyond the default set and allow you to customize the metric you want to receive. Let's explore how we can take advantage of Amazon API Gateway Access Logs to get more metrics. When we enable access logs, API Gateway will log every request to your API, including detailed information such as the request method, resource path, response code, and latency. We can enable access logs using CDK by following a few simple steps. First of all, we should create a HTTP API. This is step number 1 on the slide. Then we have to configure a CloudWatch Logs log group for our API. And finally, attention to step number 3. We should specify our log group for access logs and define its format. Format could contain different fields. In our case, we will have request ID, HTTP method, some user info, and status of our response. After enabling access logs, we can create a custom metric based on logs and get all parameters that we listed in the format field. In the upcoming section, I will provide you with an example of how you can extract unauthorized errors from API Gateway after you provide status information to access logs. And here you can see how I feel when I create a custom metrics. Okay, now that we have explored the default and detailed metrics, let's take it one step further and discuss custom metrics. While the default and detailed metrics are valuable, they may not provide all the insights you need for your specific use case. And this is where custom metrics take the stage, allowing you to track and analyze application-specific data that is relevant to your business. So let's explore how custom metrics can help you gain deeper insights into your application's performance. There are several ways to create custom metrics. For example, you can use any published metric, basic or detailed metrics, with the specified dimensions to create your own metric. In this example, the metric name used for creating a new metric object is DNS queries, which is an existing metric published by AWS for the Route 53 service. By providing a hosted zone ID to this metric using the dimensions map parameter, we are creating a custom metric that is based on the existing DNS queries metric. This metric will track the number of DNS queries, allowing you to monitor the traffic to your domain and identify any potential issues or spikes in traffic in the specific hosted zone. Such custom metrics can be very handy if your application is being used across multiple hosted zones. The second way of creating a custom metric is to combine multiple metrics with mass expression to create your own metric. Let's consider an example. The mass expression is defined with an expression that adds the values of two metrics, M1 and M2. These metrics are defined using the using metrics property, which references the metric client error and metric server error of API Gateway entity. The custom metric is then created using the metric method of the mass expression object. Mass expression objects can be used like any other metric, including using them in other mass expressions. This is a fairly common case when we create an alarm based on multiple metrics. Moreover, it can be not only the sum of several metrics, as in our example, but also the ratio of one metric to another. For example, the ratio of the number of requests received by API Gateway to the total number of errors, or it could be any other mass operations. The third way is to use filter pattern and CloudWatch logs to create your own metric. Do you remember the example from the previous section? where we have enabled access logs for API gateway, and how we provided status parameter to the format fields in these logs. On the bottom, I have a small reminder of how it was defined. And now, after specifying our access logs format, we can leverage any parameter from it. For example, create a custom metric called authorization errors with a filter pattern that matches log entries with a status field equal to 401. The metric values is set to 1, which means that whenever a log entry matches the specified filter pattern, our authorization errors metric will be equal to 1 at that point in time. This code creates a metric filter object that extracts unauthorized errors from an API gateway CloudWatch logs log group, and afterwards creates a metric for this metric filter by calling metric method with some parameters. In our case, it is a statistics parameter. The filter pattern option is used to specify a pattern that will be used to extract data from the logs. This pattern is defined using a filter pattern object, and it allows you to select only the relevant logs events that you want to include in the metric based on their content. And here is a more complex example demonstrating how to use the filter pattern method to extract the amount of memory used by an AWS Lambda function. Space delimited is a method of the filter pattern which divides the log event into fields separated by spaces. In our case, this method takes in two arguments, header and ellipsis character. Header is just a variable for the first field in our log that we have defined by spaces. And ellipsis character represents the rest of the log message after the header field. These additional fields will be assigned numbers based on their position in the log message, with the second field being assigned the number 2, the third field being assigned the number 3, and so on. We use where_string to filter out logs that contain the word report in the first part, which we have given the name header. At the bottom of this slide, you can see an example of a standard Lambda report. In this log format, the metric value that we are interested in is found in the 18th space delimited field of the log message. Do you see it? It is located at the very end of the report string, and it is equal to 96. So if we want to extract this metric value, we can set the metric value property to 18 with a $sign when defining our metric filter, which means that whenever a log entry matches the specified filter pattern, our memory used metric will be equal to any value from the 18th position in the report. In our case, it will be equal to 96. Now that we know how to monitor and collect metrics for our AWS resources, it's time to take action when something goes wrong. And this is where alarms prove useful. By setting up alarms, we can automate the process of detecting and responding to changes in our metrics data. So let's explore how we can use alarms to keep a close eye on our resources and respond to any issues in a timely manner. And of course, I encourage you to tap into your inner overmind and harness the full power of CloudWatch. Let's go. There are 3 states of CloudWatch alarms. OK indicates that the metric being monitored is within the expected range and the alarm has not been triggered. In alarm indicates that the threshold value has been breached and the alarm has been triggered. When an alarm is in this state, users can configure actions to be taken, such as sending notifications or triggering an automated response. Insufficient data indicates that there is not enough data available to determine status. When we create a metric, we provide a period parameter, or if it is not provided, it will be equal to 5 minutes by default. And then the alarm evaluates the metric once per specified duration in the period parameter. For example, if a user sets a metric period for 5 minutes, the alarm will evaluate the metric once every 5 minutes. During each evaluation, the alarm will compare the metric data against the threshold value that have been set. And if the threshold is breached, the alarm will transition into the in-alarm state. In CDK, alarm can be created on top of metric in one of two ways. The first way is to use the CloudWatch alarm constructor and pass in a metric object that you want to create alarm for. Then you can specify the threshold, evaluation periods, and any other properties of the alarm. The second way is to use the createAlarm method on a metric object. This method creates an alarm for the metric with the specified options. You can pass in the alarm threshold, evaluation periods, and comparison operated, as well as any other options that are available for CloudWatch alarms. Let's consider the parameters that we have leveraged in our examples. Threshold, it is the value to compare the metric against, or in other words, this is the threshold value that triggers the alarm. In the first example, the threshold is set to 100, which means that alarm will be triggered when we have 100 or more errors in one evaluation period. Evaluation periods, it is the number of consecutive periods during which the threshold must be breached before the alarm is triggered. Comparison operator used to evaluate the metric data against the threshold. It determines the behavior of the alarm when the threshold is breached. The available operators are greater than or equal to threshold, less than or equal to threshold, and less than threshold, and just greater than threshold. If you have multiple alarms, you can consider creating a composite alarm. Composite alarms allow users to monitor the states of other alarms and determine their own states based on the results of these evaluations. This can be useful for reducing alarm noise and avoiding unnecessary alerts. A composite alarm consists of a rule expression, which is used to determine its state based on the states of other alarms. You can use logical operators such as AND, OR, and NOT to create complex expressions that monitor multiple alarms. In this example, we create 3 alarms, Alarm 1, Alarm 2, and Alarm 3 that monitor different metrics. Then we use the all-off operator to combine 2 alarm expressions, any off and not. The any off operator is used to monitor the state of either alarm 1 or alarm 2, and the not operator is used to exclude alarm 3 from the expression when it is in insufficient data state. Finally, we create a new composite alarm using the rule expression and give it the name My Awesome Composite Alarm. When an alarm is triggered, it can perform one or more actions in response to the alarm state change. These actions can include sending notifications to users, triggering automated processes, or making changes to AWS resources. To add actions to an alarm, we have to use the AWS CloudWatch Actions package from the CDK library. In the first example, we consider EC2 action, which helps us to reboot our instance. By adding EC2 action, whenever the alarm enters the in-alarm state, it will trigger the specified command. The EC2 instance action provides various options that you can choose based on your requirements. These options include the ability to stop, terminate, recover, or reboot the EC2 instance. Moreover, CloudWatch can send notifications to Amazon SNS topic when an alarm is triggered. This allows users to receive alerts via email, SMS, or other channels. In the second example, you can see how to leverage SNS service when an alarm is triggered. For this purpose, we create an SNS topic and associate it with our alarm by adding an SNS action. This configuration ensures that notifications related to the alarm will be sent to the specified SNS topic. And in addition to EC2 and SNS actions, there are other types of actions that can be used when an alarm is triggered in CloudWatch. For example, SSM Operations Center actions can be used to create operations items in AWS Systems Manager, or autoscaling actions that can be used to modify the desired capacity of an autoscaling group in response to an alarm state change. Now let's take a look at some graphs that demonstrate how alarms are reflected in Amazon CloudWatch. On this slide, you can see a graph representing the memory used metric of a Lambda function. As you can see, the current state of the alarm is OK. And we can notice that there were a few calls to our Lambda, where the memory used metric exceeded 100. The threshold for this alarm is set at almost 205, which means that we are still within the safe limits. However, it is important to keep a close eye on this metric and adjust the threshold if necessary to ensure that we are proactively alerted if the memory usage of our Lambda exceeds safe levels. This slide shows an example of an alarm in Amazon CloudWatch that is in the alarm state. The alarm is set to trigger when the duration metric for a Lambda function exceeds a threshold of 15,000 milliseconds. As you can see in the first graph, several invocations of the function exceeded this threshold and triggered our alarm. However, as shown in the second graph, the alarm did not change its state, even after 10 minutes since the last invocation. Regardless, our evaluation period is equal to 5 minutes. This is because there were no new invocations, and the alarm state will remain the same. This is the default behavior for CloudWatch alarms. The alarm will stay in the alarm state until the matrix goes back to a value below the threshold for a specified period. By default, this period is set to 1 evaluation period. Once the metric returns to a value below the threshold, the alarm state changes to OK. And now, as I promised, a specific use case that can help you to save up to $1 million. What do you think, guys? Which answer seems right? I guess this one is close to the option don't touch anything. But it's not our case. We are going to choose tracking metrics and setting concurrency limits. And here is an example of common problem that can arise when using AWS Lambda functions, and demonstrate how you can use CloudWatch metrics and alarms along with AWS CDK to monitor and control the resource usage of your Lambda functions and prevent runaway costs. One of the benefits of Lambda is the conditionally unlimited ability to scale each individual function as needed. However, this dynamic scaling can also be a double-edged sword. It's possible for the number of requests to grow to hundreds of millions without you even noticing, and the cost of using resources turns into several $1,000s. To mitigate this risk, it's important to take steps to monitor and control the number of concurrent executions of your Lambda functions. First of all, when developing a Lambda function, always specify the reserved concurrency parameter. This parameter sets the maximum number of concurrent executions of a function, helping to prevent runaway resource usage. Additionally, you can use AWS CloudWatch to monitor the number of invocations of your Lambda functions and set up an alarm to notify you when the number of invocations exceeds a certain threshold. So, first of all, we create a Lambda function using the AWS CDK and set the reserved concurrency parameter to 5. Then create the CloudWatch alarm for the invocations metric of the Lambda function with a threshold of 500 and evaluation period of 3. Then we see that SNS topic is created and team members are subscribed to it using email. Finally, the SNS topic is added as an alarm action to receive email notifications when the alarm is triggered. So, if the Lambda's invocations metric exceeds 500 during the 3 consecutive evaluation periods, which in our case is equal to 15 minutes, the alarm will be triggered and your team members will receive the alert email. So, as you may see, collecting metrics and setting alarms is essential for proactive monitoring and optimization of AWS applications. By using the AWS Cloud Development Kit, developers can define and deploy CloudWatch metrics and alarm using code, which increases efficiency and reduces the risk of manual errors. It is worth noting that the presence of alarms in application does not guarantee that issues or errors will never occur. However, alarms can help developers proactively respond to potential issues by notifying them when certain thresholds or patterns in the data are met. This allows developers to take action before issues become critical and impact the application's availability or performance. That's all I wanted to share with you. Thank you for your attention. And at this point, I would like to start section for questions and discussions. Please feel free to ask any questions or share your thoughts on the topic. And the first question. How can I disable the default CloudWatch metrics generated in a Lambda? I don't know the direct way to disable default metrics. Probably it should be covered in CloudWatch settings, but I'm not sure that it's possible. How do we create CloudWatch alarm for multiple regions? If your application is used for multiple regions, you probably need to have a common alarm, yes, if it is if you have one AWS account for multiple regions, yeah, you can set an alarm on the higher level of your services. Can I set up only one alarm with multiple Lambda function logs at once? Yes. As I said, you can combine multiple alarms to one using composite alarm. For example, firstly, you create one alarm for one Lambda, second alarm for second Lambda, and then combine them with composite alarm, and in this way reduce alarm noise, and have only one alarm. If but you should provide a specific rule for it. Yes, you clarify a rule and have only one alarm then. Yeah. What is the difference between memory used metric from AWS Lambda Insights and custom memory used metric when we retrieve metric value from Lambda report? As I told, Lambda Insights is a paid feature, first of all. You will pay it based on the amount of log data received by your function. And in these logs, you will receive many different metrics. Probably you don't need all of them. But from other side, with custom metrics, you can retrieve only memory used metric. You can retrieve from logs that are already existed. And as a result, save some money. We have one interesting thing there. Under the hood, Lambda Insights feature collect metrics and send them as log event for every invocation of your function. Then CloudWatch uses embedded metric formatting to extract metrics from the log events. And when we created a custom memory used metric, we did almost the same thing, I guess. We have just retrieved the needed metric from logs. In our case, it was already existing logs. So we do the same thing, but don't pay for additional logs. I got confused at one point. When we are using additional configuration, at that time, the threshold value has no significance. Am I right here? Didn't get the question. When we are using additional configuration, at that time, the threshold value has no significance. Now, could we clarify this question? Do you mean that we have some threshold value and you mean default threshold value, and when we rewrite it, as I said, by default threshold value is set. We don't have a threshold value. I just mixed up with duration. Oh, honestly, I don't understand the question. Could you reformulate it? Is it important to know how often data points appear on a graph? Metric resolution when setting period plus evaluation periods plus data points to alarm values. By default, on the graph, we have a new point every 5 minutes, but it depends on the service. For example, if we have EC2 service and turn on detailed metrics for EC2 service, we will not have additional metrics. We just will have the same metrics, but more often. I mean, every 2 or every 1 minute. I don't remember, honestly. Yeah, but if we have such needs, yeah, we can change it. But we will pay more in this case because we will collect metrics often. Okay. It seems that we have covered all the questions for now. Thank you once again for joining and participating. It has been a pleasure sharing this information with you. Recording of this presentation you can find on YouTube and on Facebook as well. If you have any more questions or simply want to engage in further discussions, feel free to reach out ClickAttack virtual open house events, where you will have the opportunity to learn more about ClickAttack, its values and processes, our projects and technical challenges, connect with our team, and just to be updated on the latest news and developments. To explore more information and discover upcoming events, please visit our website at the link provided on the slide. And I wish you a delightful and successful experience with monitoring using Amazon CloudWatch. Bye.